Well, perhaps that you don't know, SPSS already has feature for power analysis and meta-analysis. But in this video, I just like to compare of the power analysis between a SPSS and gpower program. So let's find out. Just click SPSS here, and after that, we're gonna click gpower analysis. So here that you see in the screen, there are two softwares. And for the SPSS that I would like to show you here in the analyze, they already have features for power analysis here, power analysis for means, proportions, correlation, and regressions, and they already have meta-analysis here for continuous outcomes and binary outcomes, and even meta regressions, meta correlation, right? So that's a good thing to do in the SPSS. Alright, so we go to power analysis. So I would like to go to, for the means test, for the t-test first, I'd like to go to pair sample t-test. So here we go, pair sample t-test, power analysis for pair sample means here. And for the gpower, we go to t-test here. So we go to means difference between two dependent means, right? So here we go. So I choose power analysis priority. So let's try to make the same input parameters here. So tails, one tails, and here for the effect size, I'm gonna use, perhaps from previous studies, I'm gonna use just 0.3 and error 0.05 and power 0.8. And here in the power analysis in the SPSS, you can see estimate sample size here from the single power value, so 0.8. I'm gonna put 0.8 here, and so you can estimate, estimate sample size and estimate power. But because in this video, just like to see to estimate sample size, so I'll use power value here, single power value 0.8, and here a mean and standard deviations, right? So they chose population mean difference and then standard deviations, and here for directional one-sided, here one-sided. I need to determine first in the gpower here. So let's say I'm using previous study from difference, mean of difference, that I notice 0. For example, so 0.35 and standard deviation of difference, let's say 0.7. So I'm gonna input the same here. So here 0.35 population mean difference, and then for standard deviations it's 0.7. Let's check again. 0.35, 0.7. Right, so I'll just go a little bit here. Yeah. Okay, 0.35, 0.7. Okay, from difference. So I'm gonna calculate here, and then I'm gonna transfer to main window here to 0.5. Okay, so it's 0.5 here. Already goes here. And the same other test directions, already one direction, one-sided analysis, single power 0.8. All right, so let's find out. So I'm gonna close this one first. We click calculate. Total sample size 27. Okay, so this one for two dependent means, so I just need only 27 sample size. What about this? So you can see here is the same. Alright, so that's for mean difference 27 sample size, actual power 0.812, so here is 0.811, powers the same, standard deviations, effect size 0.5. Okay, here 0.5. Alright, so not much different for t-test for paired t-test. Alright, that's a good thing that we can compare about this. Alright, so let's go for another statistical test. Let's say I'm gonna go to correlational analysis. I'm gonna go for correlation bivariant normal model and then compute recurrent sample size. So here I'm gonna go to analyze power analysis and go to correlations. I'm gonna go to percent product moment. Alright, so the same thing here. 0.8 I'm gonna make like, because this percent correlation is gonna be like positive negative correlation, so I'm gonna use tails here. And for correlations I'm gonna choose medium, so I'm gonna choose medium here. 0.3. Let's see here, we choose 0.3 also, but let's say I'm gonna change to 0.15 from previous study, right? 0.15. So here I'm gonna input 0.15 as well, and here two-sided, yes, two-sided analysis, and then 0.8 here, 0.8, and here just let it for the default. So how many sample size that we need for correlation analysis? Calculate. We need 346 sample size, which is quite big because of the effect size, right? So what about this for SPSS? Right, it's the same, 346 sample size, right? Okay, it is also the same for the correlational analysis, for the power analysis, right? So let's go for another, let's say for the regressions. Let's see here, regression for the univariate linear. So let's see, it's gonna go for the same for the F test here with the gpower. For the F test, let's see here, so because there is a model predictors fixed and random, so in the choice in the gpowers they have fixed model r square deviation from 0 and another linear multiple regression fixed model r square increase. I'm gonna go to r square increase here. So fixed model, we choose fixed model first because here, right? So we're gonna go first for the power, yes, 0.8, and number of tested predictors, total number of predictors. So in this study, let's say I'm gonna use 6 predictors, and then for the tested predictors is 4. And for the effect size, let's see what's going on first in the SPSS. Okay, so here they have calculated for the also the nested model. There is no choice, no option in the gpower using nested model. But here, let's say from previous study r squared values for full models, they have like, let's say 0.43, and nested model is a subset model in the full model, so let's say is 0.20, and total predictors is 6, and nested model is, let's say, I'm gonna use 4. Alright, so I'm gonna determine here, so you're using 0.43, right? So 0.43, calculate, it's gonna be the same, right? Okay, so 0.43 and nested model 0.20. Here there is no choice for nested model. Alright, so let's try to calculate. So I need sample size 34 for the multiple regression. The sample size is quite low because the effect size is quite big, right? So here, how many sample size? 35, here 34, not much different as well, right? So there you go, the power analysis in SPSS can be used as well for calculating the sample size. So maybe that's all guys. Thank you for watching. If you got any questions, please just comment below.